Okay, today we are going to see an interesting topic. We start with the bond graph model, and we are going to end up, we want to see how, see his bond graph, we're going to see how a block diagram is produced, and also how, once you have that, how you go to SIMULINK. This is the question here. So the very first thing is, we have the connections and power goes from the source into the system, so it has to be like this. And power gets distributed to the elements, so the arrows go like this, yeah? Always power into the system. That's the norm for elements that are normal, unless there's some specific situation, but power goes into the elements from the sources into the system and gets distributed throughout. That is also consistent with the geometry of systems plus the constitutive laws that we have at each one of the junctions. So this one here, we have both one junctions on both sides.
Yes.
Yeah, okay, very good. So in here, let's see, we are going to put the causal marks in here so that we have in here like this, causal marks from the source. You do this first. And how come I erased it? I don't understand. Let's put it back. Now there you go. And we are going to put this in here like that. Yeah. And then we put the integral form for the I elements and C elements. So let's do this to the moment that I do that, I have determined the flow for this junction, so this one has to be like this. And the moment I put that on this gyrator, this one has to be like this. On this side, we do the same thing with the integral form, this flowing into this, and then you have this. Okay, so what we do to build the block diagram here is we are going to look at the individual constitutive relationships, and let's say that you have that the source is like this. We need to put some numbers first. 1 and 2 and 3 and 4 and 5 and then 6. So in this case we will do the modeling for the SE over here with the two signals here. One, that is SE, is what is going out of this. This is E1, and this is a F sub 1. And then you have this I element over here. So we have it like this, where the I element is basically, you have that the effort is going in. This is E sub 2 and this is F sub 2. So what happens here in the I element in integral form? You go in here and you have a block that actually integrates it once, 1 over S if we use the SIMULINK notation, and then out of this we'll have to come up with some gain like this, gets multiplied by 1 over I, like that. There you go. and then you have this and this. For the gyrator, we're gonna put the 2, and then also for the R element we need, see, we lay them out the skeleton of the system, and then we'll just put the constitutive relationships afterwards. So in this case of the, and it doesn't matter which way we go, building it from left to right, from right to left, or each individual. In fact, I am going to jump over here and then we'll go over here. This doesn't matter. I'm just saying in this case you see that E sub 4 is the input to this. This is E sub 6, and out comes F sub 6. So this is an integral form. So you're gonna have this is 1 over S, and then what happens here? You have a gain. We have a gain in here. Yeah, and this is 1 over I. This one in here, you see the E is what comes out. So this is E sub 5, and this is F sub 5. So if this is the case, you just multiply by the R element, by the R, and out comes E like this. So that's the constitutive relationship of this one. And then over here we have this gyrator that it says this is E sub 3, and this is, in this case, E sub 4. This is F sub 3, and this is F sub 4. Okay, so what we have in here is that this, the way we read this is, you see the input to this is F sub 3 multiplied by the modulus R over here is going to give us E sub 4. I am going to change colors because I want to see the contrast here. Oh, wait a second, now I am still on the element. So this is F sub 3 multiplied by R will give you E sub 4. So what we're saying is you have this R over here, and then this would give you E sub 4 like this, because this is F3 this way, and this is E3 is this way, and then E sub 4 is this way, and F sub 4 is like this. So if F sub 4 times R, you could write it up here if you would like, and then you do this. So we have all the elements now. I was just saying change color because I'm going to connect them. The first thing we got to recognize is here that we have a one junction on this side where all the flows are the same. So F4, 5, and 6 are the same. So I would do this. I'll just go here, and this is 4 in connection over here, like that. And then you have this, and then you're going to have the efforts to add, like this. And you have this, the 2 efforts, and then E sub 6 in here. How do we write the equation for this junction? Isn't it true that what comes in is e sub 4 is equal to e sub 5 plus e sub 6, right? Does everybody see this for this junction? But you see the way the signals go on here, two of them come in, one goes away, and the one that goes away is e sub 6. So if you rewrite this equation in terms of the one that goes away, e sub 6 is e sub 4 minus e sub 5. And if that's true, is e sub 4 is plus here, and e sub 5 is minus. So that's that. On this side, we also have the flows are the same. So I would go like this, see? Connect the flows. Yes, this is the connection here. But the efforts will sum, so we're going to write this like that. But how is the only question. How do they add up? In here, if you write the equation on here, how is it? You have that E1 is equal to E sub 2 plus E sub 3. But the way these arrows are in here, you have to concentrate on here. E2 is the one going away, and E1 and E sub 3 are this way. So E sub 2, if you write the equation in terms of E sub 2, E sub 2 is equal to E sub 1 minus E sub 3. So if this is 2, this is plus, and this E sub 2, yeah, E sub 3 is negative. Yeah, like that. And this should be your block diagram for the this model transformed from a bond graph model into a block diagram. Now, how do we do the SIMULINK part on this? That is the next issue. So what I would do is maybe I'll just reduce this picture in here, so to allow me to see it a little better. Hey, there we go. And then I'll just go into SIMULINK to give me some ability to do this block diagram. So I will have to go first and look and run MATLAB, and MATLAB of course is the main program. SIMULINK is a toolbox of MATLAB. So let's just wait and see what it does. And so MATLAB is coming, and then I have to go and look for the menu where all these blocks are. My method is that I open a new file, and then a new, SIMULINK model, new file, new window, and I bring to that window all the ingredients, all the components that I'm going to need. So let's go SIMULINK like that. Okay, so in just a few seconds it will come up with a menu that would allow me to open a new window and would allow me to pick up the elements also. So there we go. Here we have the control system, commonly used blocks. And then I pick and do the file. This is a new model, so I open the new model one, and then I will bring in this is where I need a few windows open and like this, and maybe the one I don't need is this one, but I do need this one. Let's try to have this at least visible for part of it. Oh good, I think that maybe most of it. Yeah, here. Okay, here we go. We have, let's put this is the source, yeah, here, and then I am going to need I'm just gonna bring the elements. They are not in any order that I need. So I will put in here, we need one of these two, we need another one here, we have to bring another one over here, we'll bring another summation point to the right hand side, right here, we have another gain someplace before that up here, and then we have okay, and then we have on that side we have an integrator over here that we need to do, and also we have another gain over here. Some of these gains are upside down, and just bring the ingredients like I said. In this case it's always good to enlarge this once the summations this has 3, and this has basically 2 inputs, 1 output, so which is what we want. Okay, well, we will see how we do this. From the output we're going to go here, and obviously this is the input right there, this one right here. Perhaps we might do it so that we don't have this curve like that. See, it makes it a little nicer. And then we go a little farther down here so that we also do not interfere too much with this. And then we're going to have that this goes, see, this is gonna go, I need to invert this. It's going to go like this. Oh no. Something is not happening here.
Try to put an output to an output, or an input.
Oh, it is the output. That is my problem.
They're both inputs, actually.
I think, no, the problem is that I need to flip this one, because the way it is not connected correctly. So this one is going to go like that, and this is going to be like this. Now we are in business, because that's the way it is on the graph, see? And in here you're going to go from here to here, like that. And then you have this one. We have the 2 in here. Yeah. One of them is going to be flipped, so do Control I. And then we're going to move this a little farther here. We are going to go from this to this, see? See, we're going to go, see, building a little better, more efficiently. So in here you're gonna have this. I always make this bigger so that I can see, and also that I can actually put the like in this case this is R, like this, yeah. And then we have a okay, we have this okay, this is control I, like this, and this is the R element, like this, yeah. We need the R element, this capital R. So you begin to see how this is shaping up. We have this this one in here is control I, like this. How many of this has one output, which is this one, and it has two inputs. So one input is coming from here to here, and the output goes to here, and the other one is coming from this one. See, it goes from here to here, yeah, and this one goes from here to there. There you go. And then this in here, you're gonna have a connection to the SE. That's the one that we might not see. Oh, that's the one that we may not see it here. Did you mean to scroll? Like this is what I meant. I need a bar in here. So we have this one to complete. This is going to be the modulus R again, like that, and this will come out in here like this. This is the 1 over R. Is it 1 over R? No, 1 over I. And then we have this point where the flows are the same, and that's the one that does not exist, this one. But other than this, I think we are pretty much finished, except that we have a couple of other connections here. This one is going to connect over here. This right here is going to be 1 over I also, yeah, like this. And then you have this R element is going to connect over here. See, you need the same common connection right there. And I think this is the whole thing. And we have finished your block diagram in SIMULINK. The only connection that is not here, and understandably so, is this one that puts this connected to this, because the flow is irrelevant for this, is actually a effort source, and that's what we see. So it will look just a tiny bit different when you go to SIMULINK, but it is it is the same thing as having this on paper. But that's what we need to do, from going from the bond graph to the block diagram.